Okay. So I'm guessing from the color of your shirts, mostly, that you guys know that this is the world we live in, so full of vulnerabilities everywhere. And also, I'm guessing that many of you are security researchers finding bugs. Anyone found bugs in someone else's code? Please don't be shy. I know you all have, and those who haven't tried maybe haven't raised their hands, but it's so easy. Now, as a researcher, maybe you're lucky that the vendor of the vulnerable software has a bug bounty program, but if they don't, then you are faced with a very painful dilemma, which is you want to report this to the vendor, and we know that, well, all hell can break loose if you do that, or if you can be very lucky. You can just go full disclosure and hope for the best, and then justify that in all the ways you can think of. You can sell it to, and then hopefully not read the news so you don't know what the vulnerability was being used for. Or you can just forget about it. So none of these options are really very good for you. And in case that the vulnerability that you found actually got to the vendor and the vendor created a security update, that security update is very likely to not have been installed yet. Why? Because official vendor updates look pretty much like if you go to a doctor and you say, my knee hurts a little bit, what can you do something about it? And the doctor says, of course, I will just replace your entire leg and give you a different one that doesn't hurt. That might work for doctors. I know, I wouldn't let them. But case in point, last Patch Tuesday, if you had a Windows 7 64-bit system and you applied just the security-only updates, which is a new thing now, they fixed 31 vulnerabilities, and they replaced 232 megabytes of code on your system. I'll let that sink in. So 232 megabytes. Well, of course, most of it was the same source code, but who knows what the compiler compiled. Now, this is a big reason why, well, end users may apply their updates immediately, but corporations and enterprises don't do that because too many times things have broken and they go into testing. So they test and test and test. And while they test and test and test, attackers attack and attack and attack. Because, I don't know if you know, one of the recent researches has shown that in the United States, the financial corporations take on average half a year to apply official updates, which is kind of good times for attackers. I mean, I'm a pen tester too, and it's like, cool, it's easier to break into networks today than it was years ago, because I know I can just go to Pastebin or anywhere to find an exploit and just go in. And also, why do admins fear applying updates immediately? That's because it's risky. They can break things, and also they need to interrupt their users unless they do it at night. And of course, if something goes wrong, it's very, very difficult to correct things and get back to yesterday when you were vulnerable, but things were still working. So patching is clearly a software problem. So what does one do if one wants to fix a software problem? I think it's obvious. You create more software, right? And that's what we did. We created more software. And of course, we created more vulnerabilities, but who cares? Let's look at what the software does. Now, what the software does in trying to fix this huge software fixes not being applied problem is nothing really spectacular. We're just using what every antivirus is doing, everyone who's doing anything with hooking, function hooking, and it's been done for decades, so nothing new here. But let's just say we put some steroids in there so that we can patch anywhere in the code instead of just at the beginning of functions. Now, let's say we have a vulnerability here, and we need to fix, to add some code to correct the problem so it goes away. So we want to inject the patch code after this call that we see here, and we see this is just basic hooking. We see that these following instructions are relocatable to somewhere else in memory, and that is exactly what we do. We relocate those original instructions somewhere else, and we put the patch code before them, and then we jump to the patch from the original location, and then we return from the patch code back. So it's just basic stuff. Everyone's doing it, so we're doing it as well, and it's time tested. But what we just did here is we patched a vulnerability, and we did it without, okay, flickering, cool. Can we patch this? Okay. We did this without restarting a computer and even without relaunching the process that we were fixing. So it's just hot applying a patch. Now this is a sample patch source code. Basically what you need to do is just, okay, at offset X, I want to put these additional machine instructions so I can fix this vulnerability. It's very simple. For instance, if you have a buffer overflow, what do you need to do? You need to do what the original programmer forgot to do. He forgot to check for the length of input. So you do that. You check for the length of input. If it's too long, you cut it short. Or you do some other corrective actions. But just cutting it short, just putting a null byte at the end to cut it short, and let the original code flow through. And that's a fix there. Now this is the actual fix for an all-player bug. Very simple. Now, basically, the good news is that we can fix basically any critical remote code execution, because most of them are memory corruptions, right? So we can fix double freeze, use after freeze, numerical under overflows, unchecked buffers, and so on. And if you read yesterday, some guys came up with a new exploit type for Flash bugs. It's called use after free. Cool. You can fix that too. No idea what that is. Now, this is where you guys come in, right? You guys look like a crowd to me. And also you guys look like you could patch. Why? Because if you have ever found a vulnerability in software, you have created an exploit. Of course, that's the fun part, creating an exploit, so you can show what can be done with the vulnerability that you found. You can also create a patch. That's the same skill set that you need. And this is what we're envisioning. So we're a small company, and we cannot create all the patches that the world needs. But together with you and with all the other security researchers, that can become possible. So what we've done is basically, we created a machine that allows you to patch stuff.
White people.
Sorry?
White people.
White people? I'm sorry, just the same. That's the same guy. Okay. So that's the basic idea. It's very simple. A lot of security researchers finding a lot of vulnerabilities and reversing a lot of patches from official vendor updates, and then putting them all in that gray box, which then distributes that to millions and millions and millions of users. Does that sound nice? Well, you can be part of that. I'm hoping that some of you will be. Now, what we're trying to do is turn this, the situation that we have today, into this. So, where are we at this point? We have an open beta for Windows. You're all free to try. Welcome. And give us feedback. We have a proof of concept for Linux, and working our way towards Internet of Things. So we're hoping to stop the hell that's waiting us there. We have a proof of concept for Mac, and we are just about to ship the 0Patch Factory, which is a very simple tool that makes it easy for you to create patches. So I'm hoping that you will, some of you at least, will start considering creating patches. Just at least for yourselves if you have problems, or for other people. So contact us if you want. We'll give you some info where you can start. Thank you very much.